Hey guys, today we are going to build a Rust application in Kubernetes. So the topics we will be covering today are Kubernetes networking, so ingress, cluster IPs, port forwarding, and then we will also use config maps and secrets. We will use stateful sets and volume claims for our database, and we will use a lot of kubectl and minikube. So the technology we are going to use are Nginx for our ingress, Nginx for our web server, Actix framework, that's a Rust-based framework, and then MongoDB for our database. So our architecture will look like this. We will have our ingress, and that will act as an API gateway between our Kubernetes cluster and the outside world. So when a user accesses our ingress, they will automatically go to the web server so they can get the static files. So the web page, for example, and then via the web page, they will talk to the Actix web application. So that's in the path nodes. As you can see, the port forwarding happens in the surface. So you have two labels there, port 80 to port 8080 in the deployment. So it receives the data, the surface receives the data at port 80, and then the surface sends the data to the pod at port 8080. All right. And then we're using the secret and config map to configure information as username and password and the database URL. And then we have our MongoDB application. We're going to use stateful sets for that. So we will have a persistent volume claim and a persistent volume. So the difference between that and between a stateful set and a deployment is that the deployment you're not running stateful applications. So even if it dies and you have other deployments spinning up, it's not a problem if you lose data. But with stateful set, you don't want your data to just live with the pod. You want it to live beyond the pod. So that's why you're storing the data in your volume. So your volume is not in the cluster, but you're using the persistent volume claim to claim that volume outside of the cluster. Okay, so let's start with our config map and secret. All right, we will start with our configuration. So let's create a config folder, and in there we will create our secret YAML file. So it's going to be a secret. Let's call it Mongo DB secret, and then we'll have the username and password. So for the username and password, these need to be, the values for these need to be in base 64. So the easiest way to do it is to use bash. I have Linux as a subsystem in my Windows, so I can easily do some Linux bash here. So, and if you don't have Linux, you can also use get bash. So it should also work in get bash. All right. So usually when you do echo and then a value here, you just echo the value. But what we're going to do is echo that value and then change it into base 64. And then we have our value in base 64. And then put it there. And you can use any value you want. I'm just using password and username because it's straightforward. And it's a tutorial, so that's our secret. Let's create our not our stateful set. Let's create our config map. So config map, and we're going to call this database host. And then we're going to call this Mongo service. Okay, so we have our configuration. Oh, this needs to be in here. Now we have our configuration. Let's quickly create that. So I'm using Minikube to run Kubernetes locally, and I'll have the description for downloading Minikube, and to run Minikube you need Docker as well. So let's do Minikube start. All right, let's apply our files so we can create our resources. So apply flag for file name. So we'll just put the directory name config, and then it'll run all of the YAML files in that directory. All right, so let's go on with our MongoDB. All right, so now that we have our config, let's create our database. So I'll put it here. This is not like a standard way of organizing your files. I'm just organizing it like this because it's easy for me to see where the different resources are. So stateful set YAML and stateful set, I'll call it Mongo. Stateful set, I'll call this Mongo. Well, the app is going to be K8 notes. I'm going to call this Mongo service. I don't think we're going to use the service name in this tutorial, but since it's there, we are going to fill it in. Right, let's just see mix. Okay, we're just going to use one replica for this tutorial, just one main database. Right, so we're pulling it from Mongo, and container part is going to be 2. Yep. So all of this, so usually when you work with containers, it's always a good idea to work with the container documentation. So for example, we're working with Docker Mongo. So usually it's good practice to read over this so you understand what's happening, and you can also see what the host name usually is. It's 27. Yeah, so this is it by default, so that's why I'm changing this port to 27017. So we're changing the name as well. Well, we don't need a name. Let's just get that out of the way. Go persistent storage, that makes sense. I think that's good. We'll call it the same. Yep. Read write once. This is too big. We don't need that much storage. Okay, right. So let's create our service as well. I'll put it up top. Service. And then we'll call it Mongo service. This is going to be K8 out. We'll just keep it at the same port. Okay, we have our service. We also want to make this a headless service because we're working with a stateful set and we want more control over the flow. Because in the case of having more replicas, we would have one read-write database and other read replicas. And then whenever you want to read, you will send the traffic to the read replicas. And whenever you want to write, you want to make sure that you're actually writing to the main database. So the way we do that is by saying cluster IP none. All right, so now that we have our database, we need to be able to authenticate into our database if we want to communicate with it. So now we have to create a user to do that. So let's create our, wait, do we have our stateful set already? Nope. So let's create that. kubectl apply file name. Right, it's created. And then the next thing we need to do is run some commands in the pod. So kubectl exec, and the -t and the -i give you control over the pod in the MongoDB pod in Kubernetes. So now we have to give our pod name and then our initial command. Awesome. So that's it. So we have to switch to the admin database, and then we are going to create a user. So all of this, what I'm doing here, you can find all of the information in the Mongosh documentation. I will also have the links in the description for all of the code I'm using. So create user, then we need user, which is username in our case. So you have to use the values you actually used in your secret here. And then password is password. Awesome. And then we need to give our roles. So it's going to be a overpowered user. We're going to give him root roles because I don't want to focus on databases right now. So we'll just keep it very simple. Admin. Then next line we have this, and this, and this. Good. If you get a response of OK and 1, you should be good to go. So we created our user. So now we can go on. All right, let's move on to our Rust application. Before we dive into coding, let's just use a mind map to understand what's happening. So the user is going to send data. So when we receive data from the ingress controller, it's going to talk to our API. And we're using Actix web for that. So, and this is in our Rust code. So the data we receive is from the ingress controller to the service. And then in our container, we have the Actix web that handles our API. It makes it a lot easier to work with Actix web or Rocket instead of creating your own API. Okay, so then we have our repository, and that's going to communicate with the database using the MongoDB driver. So these are all libraries that we will use from MongoDB and Actix web. And then between these two, we have our bridges. So the first one is our model. So that's gonna make sure that we use a consistent schema to communicate between the API and the repository. So MongoDB uses collections to organize their data. So we will transform that using the model into a struct that you can use in Rust. And then for our controllers, this is more to control to transform the functions. So we will have CRUD functions in the API and CRUD functions in the repository. So the ones in our API are tailored to how Actix web handles incoming requests, and the CRUD functions in our repo are tailored to work with how MongoDB driver needs to understand the data to be able to talk to the database. So this is what it looks like. And every time you get a little bit confused or lost, you can come back here and look at this mind map and understand what's happening here. So we're going to use Serta to do some serialization between the bson, which is the data type that MongoDB uses. So bson into structs, which we will be using in Rust. And then futures will help us to asynchronously um, talk to our database. Awesome. So now we will go to the Rust part of this project. So let's do cargo, new Actix app. And then it created everything for us. So let's cd into Actix app. So you can see everything here. So this is going to be our main function. So let me close others. So the first thing we are going to set up is our Actix library or framework. So let's quickly go to Actix web. So if you go to there, getting started, you can see that you need to add this to your dependencies. So let's do that. So your dependencies are in cargo.toml. You just add it here. All right, so it's done. So it automatically adds all of the files you need to run your Rust application. So now that we have that, let's also work with their starter code here. So that's located there. So just replace all of this. And then they have their main function here. Yes. Awesome. So let's test that this works. So to test this, you can do cargo run. All right, it's done compiling. So we compiled an executable file, so you can see where that's located. So it's a target, debug, and then you should be able to see it here. So it's just running this here. So we exposed it at 8080, so we should be able to access it there. So let's do git localhost 8080, and it works. So that was this here. So this is where you can see the path. Here you can see the code that is going to run. So let's do our echo. For the echo, it should respond with the body that we sent in. We're sending this body in, and it's responding with this body in the response body. So let's do that. So it's echo, then it's post body. Let's do JSON. Let's say hello world, and then you get the same body back. So we're just testing it. All right, since we've tested this, we can stop our process here. So Control C. And then now we're going to add our driver, our MongoDB driver. So if you go here, let me do MongoDB drivers. You can see the different drivers here. So let's do view all languages and then Rust. So once you have Rust here, there's a whole lot of documentation about it that you can read. Here's very useful information. So let's start here though, because you want to see what we have to put in our dependencies. So quick start, download and install, and then you can see our dependencies here. We won't be using Tokyo, we don't need that, but we do need this, and we need this. We need these two. So let's add them. And then we also need this. All right, so let's start with our code. So in our repository, we're using the MongoDB driver, and then instead of doing use MongoDB bson, MongoDB error client collection, we just import it like this, and we're doing the same thing in here as well. So that's that. We're using the crate from model. We're using the node model. So we are going to need this throughout the application. So this just gets the object ID from the MongoDB driver because we want to set the type to ID. MongoDB, their ID type is it's like an object with ID in it and then some other data. And then the Serde package to deserialize and serialize. So this is how you use that. So if you want to see more about how to work with Serde, the link will be in the description as well. But um, they have everything here. You can quickly go to bson because that's what MongoDB uses, and then you should be able to see some some code you can use. So it's pretty straightforward. So for example here, because this is what we're using. So I'll have those links in the description as well. So that's what we're using here. This is a little bit deeper in their docs. This is just to rename the ID to underscore ID because that's what it's called um, in in MongoDB. And here, based on the documentation, um, it will skip serializing if option is not. So if when we create anything, we're just going to create title and content, and the ID will be auto created by the driver. All right. But when we get data, we are going to get the ID from the database, and then we actually do want to serialize it. So that's the model. And then here we have our node repo struct. We're going to expose our client. Well, actually, we will we will have a client here, but that's only for the test. So this stays private, and this will be public because we will be using collection for the CRUD functions later on. So here we're just setting all of our environment variables, and then we're creating our connection string. I have to do this because I get new lines for some reason. So just to get rid of the new lines, I use trim. And this here, how to connect to the database. You can find that in the MongoDB documentation. So if you go to fundamentals, connections, connection guide, you can see what the URL should look like. And then you can also see some code you can work with. So whatever we're doing is very close to what you're doing here. And that's the thing with when you're coding, right? You just take examples and then you change the code to what you need, because this won't work copy and pasting. You have to actually um, adjust it to what we did. So so here we have a client. There's a function that's named with URI string. So the URI is here. We're putting that as a variable as a argument, and then we should get our client out of that. If it fails, it will send us a message, an error message that it failed. And then our collection here, this is how we initialize it. So client, then the database. So this is the client we just created here. Client database. So we're going to create a nodes database and then collection nodes on that database. And then if that all is successful, we say connected to MongoDB. All right, so that's that. And then we have a test function here. We have our return statement here. This is also you can also find this in the documentation. And then we have this here. So if you want to know anything about how I found all of these functions in are the methods in the driver. It's very, you can easily find it here. So let's go for example, CRUD operations. If you go to read operations, let's go to retrieve data. Um, they're doing it like this, but we're using a model, so we don't have to do it like that. And then you can see different examples of how to do it. You can also see the return types. So let's see. You can also see, yep, you can also see the return types. So you can use that in your function as well. So that's how we composed our return type here. So, okay, so you're using this client, this database, and you're running a command. So since this is a test, we're just doing a ping. Then we should receive an OK equals 1 from the database. And if we receive that, we return it. If we don't receive that, we throw an error. So that should be it. So we already looked at a repo, the model. So the API is straightforward. This is just Actix. So we use the node repo here, and then we access it and use the test function. And then the test function will return something. And if it returns something, we will return that with an OK status and then this body. If it doesn't return anything, well, then it's an error, and then we will return the error message. Okay, so that's that. So if you see this here, so Actix web data, that's also from the documentation. So let's quickly look at that. So if you go to Actix webs, you go to documentation, go to patterns, databases, and then you see the documentation for MongoDB here. It's slightly different because I changed my code to what I need. But you can see here the web data, and then you put your client here. So every time we need to use the node repository, then they call theirs client. Ours is node repository, and then you can access that client. Okay, so that's the API. And then in our main function, we're putting everything together. So we have to declare our modes here and our modules here. And you really want to do this before you really start coding too much. Otherwise, you won't get any linting in these folders, in these codes, in these files. So we're importing these. We don't need this yet, but let me just and this is all from Actix Web, and then this is the function in our API for the test function. Okay, and then this is where we test that Actix is up and running, and then in our service, just as the initial setup, we have our service declared here, and then we put our test Mongo here as well. I changed this to all zeros because when it's running in Kubernetes, it doesn't always work with the 127 with the localhost. Okay, so that's that. Let's see. Okay, and this is important as well. So this is where we actually initialize the connection with the database. So all this does is it imports the node repository and then the initialize function. So this is the initialize function. And then it returns a connection. Then you have your node repo, and then you put your connection into this. And this is all Actix web documentation. So you should be able to see them doing it here as well. So yeah, so the URI, and then they do with URI string. And then when they get the client from that, they return the client, and then they do this step here with app data, web data, and then new client clone. So it looks a little bit different, but it's the same thing. So add data, and then the node repo we got here, then we do clone, and that should be it. So there's a little um, little detail you need to focus on. So for example, I did image pool policy. If not present, I would recommend you to use Docker Hub. But I want everything to be self-contained in the tutorial. So I'm just going to use local images. But if you want to use local images, you need to put this to if not present, or you can put it to never as well. And the other important thing you have to do as well is because you're using Minikube, when you're building your image, this is going to be on your computer, but it's not going to be available in the Minikube environment. So we need to do this little trick to do that. So I put it in the commands. So this here, I found it on this link. So pushing images, and then you have the different kinds of way you can do it. I'm using Windows, so I use this one. And then you have to make sure that you're actually um, then you have to make sure you are actually using that same terminal, because it binds the terminal to that to the minikube Docker daemon. All right, and then so let's run this. Okay, and then when we run this, we can now run Docker build. Okay, Docker build. Okay, we're not in this directory, so I have to change that to Actix. Yeah, and this might take a while. Okay, now we can see that it's done. So we have our Docker is also now in our Minikube environment. So we can then do kubectl apply, and then the file name, Actix folder, and deployment. All right, and then let's do a get pod. So it's running. So let's do let's check the logs. Okay, of course you're not going to do this in production, but just for testing, I have this printed out. Okay, so let's test it. So we only have a cluster IP for this. So if I do kubectl get pod, or actually get service, you'll notice that for the Actix app, I don't have an external ID. You can set node port in your YAML file if you want that. But since we're using Minikube, we can still connect to the cluster IP for testing. So let's do that. Minikube service, and that's Actix. Cool. So we have this here. That's weird because should have given us a OK or something like that on that page. But let's test it. So if you do test Mongo, yep. So we are getting our OK from the database. So let's see if this works as well. This has not found. What do I have for that? Interesting. Is it still at the same? Because I had this first. Okay. So this didn't change. So we might have to check that. Okay, so I added the CRUD functions. So in our model, we have to put these to public. because we are going to use this model in our functions. And then in our repository, well, let's look at our repository first. So in our repo, we have our initialize function here, or test function here, and everything else is the CRUD functions. So documentation, I'm following the documentation very closely. So it's very close to what it looks like in the docs for MongoDB. So um, we have a vector here, and we're assigning that to the node variable, and then we're using a cursor. That's basic database, how you go over different records, and then we push all of the records that we get into the node vector, and then we push that. So all of the other functions are very close to what the documentation looks like, and so these are actually like our controller functions, and then that's mapped to the API functions here. So here you have our path. This is the test function we tested earlier, and here we have the different paths that we can use. And then all we do is we're using the node repo, and then the function is getting called, and then if the function returns anything, we return that to the user, and if not, we're returning an error. So that's that. And in the main.rs, we have to add all of these to our service, and we should be good to go. Right. Okay, so let's build our updated image. So let's just make sure our terminal is connected with the Docker daemon, and then we will do Docker build. I'm going to change this to Actix app, and then Actix. Awesome. And then we need to, nope. Let's just copy it, no new line, and then change this as well, Actix app and Actix. So that way we know for sure that we're using the correct image. Okay, so now I'm going to redeploy our deployment. So kubectl rollout restart, and it's going to be Actix app kubectl get pods kubectl logs. Good, looks like it's working. So let's test it with Minikube. Good. So now we know we're using the correct image because we did some tagging. So don't forget to tag your images. All right, so test Mongo, that's good. Oh, from Actix. Okay, so now let's put some data in. So let's post, and then in our body we have to send JSON. So it's going to be title and this service. Then I believe I called it content. A service without a cluster. B. Okay, so that's our first node. Let's see if it works. 404 not found. Node. right? Let's see, Node API. Yes, it needs to be Node. Good. So now we have our object ID. Let's test if we get a node. So get, and then here, and then you can see we got the ID. I think I have to change something in the survey because it should transform this back to normal ID, so the user doesn't have to worry about all of that PSON stuff going on. All right, so let's do a patch. So let's update. Um, let's put an emoji there. Then we'll patch it, and it says that it worked. So let's see if it's updated. And there you can see it's updated. Let's add some other ones. So let's say cluster IP IP that exposes in the Kubernetes cluster. So no outsiders allowed. All right. So that's post, and we should remove this. Okay. So now if we do a get on nodes, we should get 2 nodes. And there you have it. Headless service and cluster IP. So it works. Let's delete this one. Okay, delete. Then let's do a get again to see what happens. I think that part, yep. And then we only have one. Okay, so now we know our app is working. The only thing that's left to do is the ingress and the web server. All right, and for the last part, we're doing the web server and ingress. Let's create an nginx folder, and in there, I'm going to say deployment. That's going to be for our web server, and then another one for our ingress. I'm going to call that ingress. So we've been testing with Minikube service, but we don't actually expose any of our pods in our cluster to the outside world. So we're using an ingress where we can control the data, and we can apply authorization and things like that. We won't do it in this tutorial, but it's just the same concept as a proxy or API. So ingress, but we're going to work with deployment YAML first. So deploy. So this is going to be our web server. Let's call it web server. And this is going to be nginx. And then we will expose it at 80. Good. Let's also create our service. So service web server, web server 80, 80. Good. Okay. And then we'll add our web our web page. So I asked ChatGPT to create the code for me. So I'm going to copy paste that. So ChatGPT created this for us. Don't use this in production or anything like that because we're using inner HTML and things like that. So just because I didn't want to spend time doing this, so ChatGPT did this for me. Awesome. So now we have our index. We have our deployment. Let's make our configuration file. So if you want to see how you have to work with Nginx as a web server and Ingress, you can, as always, look up the docs of their image, and then you can see all of the steps here. You can also see which ports they use by default. All right. So what we're going to do here is set up our config file. So nginx.conf, and I'm just going to copy paste it here. So this, for some reason, if you don't have this, it's not going to run. So even if you aren't going to put any data in it, just put it there. And then you have your HTTP and our server. So it's going to listen on 80, and that needs to be the same as here. And then your server name, localhost. This is probably going to be another name if you actually have a host name or something like that. And then the location is going to be here. We're not going to do any routing here. It's just everything goes to here. The only thing we're doing is we're serving the web page. And then we'll have all of this information here. But then in order to make this work, we're going to create our own image. So let's create our Docker file, which is going to be straightforward as well. So what it does, we're going to use Nginx as our base image, and then the Nginx configuration file, we are going to copy that into here, and then the index.html that's here, we're copying that into here. And you have to make sure that this is the same as this here because it's going to use this as the root. All right, so now that we have that, okay, so now we have that, let's build our image. And the same thing as always, just make sure you run this command first, and then you can build your image. And then Docker build should be somewhere here. Docker build. And then let's call this latest. Good. And then we can tag them correctly. Latest. So let's change our deployment here. Good. So now let's do a kubectl apply. File name is nginx deployment. Nginx deployment. Yep. All right, it's created. All right, so now that we've created that, let's work on our ingress with K8 ingress. We won't have a host. We'll just use the IP address. The service it's going to use. So, okay, so whenever you go to the website, it should go to the web server. So let's see, the service we use here is web server. So we'll call it web server. And the port should be 80. That should be the same as this here. Okay. And then we have another path. So our front end can talk to our back end. We need to add path We should probably call it API, but I didn't. So notes. Let's see, backend service. So the name should be the same as the Actix app service, which is Actix app. And then the port there, what is it? It's also 80. Good. So now we have to apply our ingress. I think I need it. I need that there. Let's see. This is why I copy paste most of the time, but I think this is a newer version of the way it was done in the past. So, okay, good. This is rules array. So I didn't put the dash here, so I didn't know it wasn't correct. All right. Now that we have our ingress, okay. So if you do a kubectl get ingress, we should be able to see our ingress here. We didn't put a host, so we're just going to use the address. So normal cases you have your address, but since we're using minikube, it doesn't assign an address to it. So with minikube, if we list our add-ons, we will see that this is disabled. So we want to enable ingress. Okay, so now it's done. Let's do minikube tunnel. All right, and then we should be able to open our web page. So we have localhost here. Let's refresh it. Oops. Let's see if we get something from nodes from our API. Okay. So our API works, but our web server does not work. So let's see what that's about. The mistake we made is not putting the image pool policy. So that needs to be, let's put it to another. Detail apply nginx. Cool. So now we'll do kubectl get pod, and it's running now. Awesome. So now it should work. So if we refresh it, we can see it here. So this is the one we already have. So let's create another one. Let's, you know what? What else can we learn here? kubectl. kubectl and application that eases the use. Eases the communication with the communication with the Kubernetes API. Create node, and then let's refresh it, and then we have it here. Okay guys, thank you for watching, and I'll see you in the next video.